Okay, today we're going to learn how to use something called Dead Reckoning to make our robot move autonomously. Whenever you start, this is kind of your basic code that you get. The name of the program is called Simulator. Let's see, yeah, that's all what you call it. And then initialization is stuff you do before you start the program. Remember, when you do this on your in the driver hub, it'll initialize and then you hit play. So during the initialize, it'll do some stuff if you want it to, and then you have to play. Now, there's a while loop. We're not going to use this right now. So what we want is we want this to go straight forward and get to the flag here. Okay. All right. So what I'm going to do is I'm going to go up to my motors, and we actually have two motors. I'm going to grab dual, and I'm going to put them right here, not in the while loop. Now I'm going to hit run and see what happens. All right, so each motor is at full power. One is full power, -1 is minus power, but it's spinning in a circle. It's not going straight. It should be going straight. And the reason is because of how we designed the bot. One of the motors is actually flipped backwards. They're mirror images of each other. So what I'm going to do is I'm going to go up to my motor actuators, and I'm going to grab this one right here. I'm going to put it in the initialization. So this will happen before it. And I'm going to set the motor left to reverse. Okay. Now, every time it sees this, it'll reverse whatever it sees. So motor left will actually be going -1. So let's see what happens now. Boom, that is great. And it goes up. It looks like I'm done, but actually I'm not done. Nope, not done. Because I've run into the wall, and if this was a real bot, it would just be keep going forever. So we got to get this thing to stop before it gets to the wall so we don't bash up our bot. The most logical thing to do would be to just throw in some zeros here and make the robot stop. But you can see when I run it, it just stopped immediately. And the reason is because the computer can go through this so fast that it does this and it just jumps right to here. So we actually want to stop the computer from thinking. We want to pause the program and sleep it so it can do this stuff and then it'll stop. So I'm just going to go over to linear op mode, and I'm going to use this one called call simulator sleep. So I'm going to put it right in between our ones and our zeros. And the reason I do this is so that it'll do this for 1,000 milliseconds, 1 second, and then it will stop. Let's see what happens now. Let's see, looks good. And I'm still running into the wall. That's not what I want. Maybe I'll try 400 milliseconds. All right, let's see here. Let's see. Ooh, that was good. It stopped, but it didn't quite make it far enough. So I'm going to go 600. Let's see. And there it goes. I could even maybe make it go 700, but that's pretty good. I do want to stop completely on that circle. That's how I know I really did it right. All right. There it is. Oh, that is perfect. It's not crashed into the wall. It stopped perfectly on that circle. Now, just a quick recap. I made both motors go at full force. That's 1. And then I had the program stop and let it go. It went to sleep because otherwise it would have just run right through. We want to pause the program so it can do this. Milliseconds 700. And then here we have motor left and motor right set to 0. One other thing is that we, at the very beginning in the initialization, before the program even begins, we're going to make the motor left just go reverse of whatever we tell it to for the rest of the program. This fixes the fact that they're mirror images of each other. All right, I hope this helps explain what's going on.